Hello grade 8s, this is Mr. Miller and welcome to lesson 5.4 on the surface area of a cylinder. So first for numbers 1 and 2, let's fill in each blank. If you look at the net of a cylinder, it's made up of one rectangle and two circles. And so it looks something like this. We'll have a rectangle as well as two circles. Let's just make sure they're the right color. Working in blue. And that is thick enough to show up. Alright, so here's one circle on top. And copy and paste that. We'll put that onto the bottom end. So basically, if you had a soup can and you were able to cut off the lid with a can opener, cut off the bottom end, the can opener, you'd see those two circles. And then if you were to cut through the lateral face or that curved surface, what you would find is that you unravel it. It's kind of like the label on a soup can, which is a rectangle. So the width of that rectangle in the net of the cylinder is equal to the circumference of the circle, which circumference is just a fancy word for the perimeter of the circle. And so when you're looking at this, we have the height of the cylinder here. So originally the cylinder would have looked like this. Oops, let's try that again. Something like this. Okay. And so you can see this is the height of the cylinder, and across here this label of the soup can has to be long enough to wrap around the soup can, so that would be the circumference of the circle, which you can calculate by doing either pi times the diameter, or you can use that the circumference is 2 times pi times the radius. And that is because of the fact that the radius of the circle is half of the diameter. So if you wanted to calculate circumference using radius, you'd have to multiply by 2 and pi. So to get the formula for the surface area of a cylinder, here's what you do. We have the rectangle, which is pi times the diameter times the height. Pi times the diameter is the width of this times the height. And then you've got pi times r squared, which is the area of each of these circles. So this has a radius of r, same as here we have a radius of r. And there are two of them, so 2 pi r squared will factor in the two circles. So if you want to do it the other way, you can do 2 times pi times the radius times height plus 2 pi r squared. So let me just do a little bit of color coordinating here so you know where things are coming from. So first of all, the pi times the diameter times height, okay, which is the same thing as this, 2 pi r h, that is the area right here of the rectangle. And of course that rectangle is what wraps around the lateral face of the cylinder, so we're talking about this part right here in the original cylinder. The other piece to this, the 2 pi r squared, is really just referring to the fact that we have two circles. Okay, so we have this circle up top here, which is pi r squared, and we also have the circle on the bottom here, which is also pi r squared, and that's why we write it as 2 pi r squared, because there are two of them. And so that corresponds to the top of the cylinder right there. Okay, so you can do it either way. You can calculate the surface area using this formula right here, or you can use the formula on the bottom here, and either is fine. They'll both do the same job. So let's take a look at how you do that calculations. We're going to take a look at how you can estimate the total surface area and then how we can actually calculate the surface area. So there is one example that's already done for us. So for instance, if we had a radius of 2.8 centimeters and a height of 10, the area of one circle would be pi r squared. Pi is actually equal to 3.14159 ... and so this is approximated by 3, and the radius is 2.8. That's also close to 3. So r squared, 3 times 3, that's 9, times another 3, that gives you 27 square centimeters for the area of one circle, which means the area of two circles, to get this, you just have to double it. The area of the rectangle is, it's length times width for a rectangle, but the way that I used a slightly different version of a formula here, I would do pi times the diameter times height. So that's how I labeled things here. And so for pi, we're saying it's approximately 3. The diameter is 6 because it's twice the radius, so 2 times approximately 3. And the height of the cylinder is 10. Multiplying all three of these, we get 180 square centimeters. So the total surface area is the two circles, 54, plus the rectangle, 180, which gives you 234 square centimeters. And so now we're going to do a similar calculation of our own. So first starting off with pi times r squared. So that would be approximately 3 for pi times the radius, which is 5, and we're going to square that. So 5 times 5 is 25, times 3 would give us 75 square centimeters. And so now if we just multiply this by 2, this gives us 150 square centimeters for the area of the two circles. And now doing pi times the diameter times the height is approximately 3 times the diameter, 2 times the radius, that would be 10, times the height is 6. So that would be 180 square centimeters. So add the area of the rectangle, which we just found to be 180, with the area of the two circles, which are 150 combined, and this gives you 330 square centimeters for the total surface area of the cylinder. And just one more time practicing with this. Again, if you're going to do pi r squared, it's like finding the area of the circle, which is approximately 3 for pi, if we're just doing an estimate, and times the radius. Well, 6.2 we can say is approximately 6 squared. So 6 times 6 is 36, times 3 would give you 108 centimeters squared. Okay, and not that I would expect you to be able to do 3 times 36 in your head. You could certainly use your calculator for that. 3 times 36 will give you 108. And so now doubling this, multiplying by 2, you get 216 square centimeters. And doing pi times diameter times the height for the circle, this would be, again, approximately 3 for pi, multiplied by the diameter, so that's 2 times the radius, which we said was about 6. So that would be 12, and times the height, which is approximately 12 as well. So 12 times 12 I can do in my head, that is 144, but multiplying by 3, that gets to be a little bit challenging. So let's use a calculator for that. That gives us 432 square centimeters. So adding on the 432 square centimeters with the 216 square centimeters for the area of the two circles will give us a total of 648 square centimeters. So those are just estimates. To get the calculation exactly, or a little bit more exactly anyways, what you would do is, instead of using pi is approximately 3, you use pi equals 3.14. So we're going to go ahead with this 3.14, which the textbook tends to like to use. Okay, so even though pi is actually not exactly that, it is, take a look on your calculator, pi has more digits than that, 3.141592, blah, 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 blah. But it goes on forever and it never repeats. So at some point, it kind of makes sense to maybe do some rounding. And so the textbook, with all the questions it does, uses 3.14 for pi. That's really handy to know, because when you're doing textbook questions and you're going to check answers in the back of the book, you may find that your answers are slightly different from the back of the book, especially if you have been using your pi button on your calculator. So for me, to get the pi button, I have to press second and this button, and that gives me the little pi. And you can certainly do your calculations with pi, but just realize you're going to get a slightly different answer than the back of the book will have, because they're only using 3.14. If you'd like to have an exact match, use 3.14, and then it'll be easier to check your answers in the back of the book. Alright, so to calculate the surface area exactly, you are going to do surface area equals, so 2 pi r squared plus 2 pi r squared plus 2 pi, pi times the diameter times height. But I do want to point out that the surface area can be done in a different way. You can do 2 pi r squared, which is the area of the two circles, and you can do 2 pi r h if you like as well. So doing 2r, that's the same thing as d. So in any case, you can do 2 times 3.14 times, we're using r equals 5 here, plus 3.14 times 10 for the diameter, because it's 2 times 5, times the height is 6. And so we'll put our final calculation here to the right. Let's see how that would get calculated out. So doing 2 times, now I could use the pi button on my calculator, but actually I know that the textbook tends to use 3.14, so I'm going to use that, times 5 squared plus 3.14 times 10 times 6. And this gives me 345.4 square centimeters. You can see our estimate was slightly different, but pretty close. So 15.4, being off by 15.4 out of a total of 345.4, that's pretty darn accurate. right? 15.4 out of 345.4 as a percent is only an error of 4.5%. So not very much. All right, so next cylinder, we are doing 2 times pi, which we're using 3.14 for pi, times the radius squared plus 2 times pi times the, oh yeah, and for pi, of course, we're using 3.14, right? 3.14 times the radius, which is 6.2, and the height, which is 12.3. And so doing that, 2 times 3.14 times 6.2 squared plus 2 times pi 3.14 times 6.2 times 12.3. And this gives us 720.316 centimeters squared. Compare that with 648. You can see that it's off by a little bit, 70.316, 72.316. So it's off by a little bit more this time. 72.316 out of 720.316 as a percent is 10% error. That's a little bit on the high side, but the reason for that is because we rounded both the radius down to approximately 6 and also the height down to approximately 12, and that makes the overall calculation a little bit off. In any case, that takes care of our lesson here for 5.4. You can pick any 8 questions that you'd like out of the textbook. Thank you for watching this video, and have a lovely day.